All right, so video number 4, we are now going to assign RRS to all asymmetric centers in the compound. So now I need to check to make sure that I need to check for all my asymmetric centers. So we know that the carbons on the end are not going to be asymmetric because they both have multiple hydrogens. But if we get to this the second carbon here, I see that I have a bromine on it. Well, I know that there should be a dashed hydrogen, so these are different. I do have 2 carbons here, but these carbons are not exactly the same because this one has 3 hydrogens, whereas this one has another carbon, a hydrogen, and an oxygen. So therefore, those are not the same. Those are going to be different. So yes, this carbon that has the bromine is going to be asymmetric. All right, so let's keep going. Now I'm going to look here. So I know I have a wedged hydrogen here, so let's go ahead and draw it in. So I have an OH and an H. Those are different, or oxygen and H. Those are different. I do have 2 carbons, but these carbons are not exactly the same because one has a bromine, one has a chlorine. So yes, this carbon that has the OH group is going to be considered asymmetric. All right, let's keep going. Let's look at this carbon here. Well, I have a nitrogen and a chlorine. Those are different. I do have 2 carbons, but these carbons are not exactly the same. This one has 3 hydrogens, whereas this carbon has another carbon, a hydrogen, and an oxygen. So yes, those carbons are not identical, so therefore the carbon with the amine is also asymmetric, and then we know this has 3 hydrogens, it will not be. So I have 3 asymmetric centers in this structure, so we are going to assign RRS to each of them. So let's start with the one on the far left. So bromine is going to be my 1, hydrogen will be my 4, and then this had the most hydrogens compared to this other carbon, so that will be the assignment of my groups for the first asymmetric center. I will then check for my lowest to be in the back. It is. So I will go 1, 2, 3. Therefore, this one will be R. Such a surprise with how I draw my compounds. All right, so we have the first one done. The second one, we'll assign our priorities. Well, oxygen is higher priority than my carbons and my hydrogen. Be careful. Do not just go, oh, bromine's highest priority, 1. No. We first look at the atoms immediately bonded to the asymmetric center, which is here. That is a carbon, carbon, hydrogen, oxygen. Those are the first 4 that I am comparing. So that's why oxygen is 1. Hydrogen we know will be 4, so let's go ahead and knock him out. Now I would compare what these carbons are bonded to because I don't have a difference in atomic number between carbon. This is where we'd say, oh, this carbon has a bromine, whereas this one has a chlorine, also has a nitrogen. But bromine has the highest atomic number, so therefore it wins. So that means this side will be 2, this side will be 3. And that's how we do the assignment for the center carbon. All right, so now I'm going to check for my lowest to be in the back. In this case, it is not. It is on a wedge, so you can't do the idea like if you do clockwise, counterclockwise right now, you can say it's the opposite answer, or we can practice double flip. So I'm going to practice double flip here. I see that hydrogen is here. My 1 is what is on the dash, so I know that means 1 and 4 need to flip. And then 2 and 3 will flip after that. So now I'm going to go 1, 2, 3. All right, if I go 1, 2, 3, this is actually counterclockwise, so this would be S. All right, this is why I change colors a lot because we get really messy because there's lots of things going on. And then for my last one, all right, so chlorine is going to have the largest atomic number. Nitrogen will be next. And then the left side will be 3 because this carbon has the most hydrogens. So there's my assignment. Now, this is where I would be cautious about assuming that, so we see that the lowest is not on the back, it's in the plane. This is where I would be cautious about saying, oh, it's just going to be the opposite answer. That's not the case every single time when it's in the plane. So this is a scenario that I would only do double flip because I'm just, sometimes it does change, but then sometimes it doesn't. And I do know how to write problems where it doesn't. So that's my cautionary tale for you if that's your technique you're gonna go with. Anyway, so here for double flip, I see that 4 is here, 1 is on the dash, so these two need to flip, and then I'm gonna flip 2 and 3 as well. Now I can do 1, 2, 3, and this one is R. Now I don't like this. In the last couple of videos, I think every time we've done double flip, 1 and 4 flipped every time. It is not consistent. So it's not that, oh, I just flip 1 and 4 and I'm good to go. That's not how double flip works. Double flip works by just looking at where 4 is and you switch with whatever group happens to be on the dash. It could be 1, it could be 2, it could be 3. So don't try to memorize double flip like that where it's like, oh, it's positions 1 and 4. That will not work and you will get things wrong. Hopefully in the next in the next slide, I have a situation that's not 1 and 4. Alrighty, so we finished the assignment here where we had RSR.